Hello again. We're working with the quotient property of logarithms, and I went ahead and put the property down. I might have not prefaced it before, but I'll go ahead and say it again. Basically, b, m, and n in all these properties have to be greater than 0, and b cannot be equal to 1. I know I've said that in the introductory, but it never hurts to say it again. Basically, it works very similarly to the product property of logarithms, except instead of product, multiplication, it's division, or quotient, and instead of addition, it's subtraction. So multiplication expands to addition, and division expands to subtraction, at least with respect to logarithms. I guess it's true here too. Alright, so here we go. Log of a base of a number of m over n equals log base of m minus log base b of n. And what I like to tell students to try to make it a little bit more helpful, I don't know if it does make it that much more helpful, is that when you're working with the quotient property, make sure you put it in parentheses. It just seems to clarify it easier, at least in my experience, that's what I've seen. So I've got this problem, and I kind of started it the same way, but usually students already know what's coming up now. Log base 3 of 5 is approximately 1.465. Log base 3 of 20 is approximately 2.7268. I want to know what log base 3 of 4 is, but I don't have a log base 3 of 4 here. I'm lost. I can't do anything. Well, actually, that's not true. I can. We're doing division here, and I want to get a 4, and all I'm given are the bases, sorry, not the bases, numbers 20 and 5. How do I get a 4 from 20 and 5? And then I sit there and I wait for a student to say something like, and then somebody says, can't you just divide 20 by 5? And I'm like, yes. That's it. That's what you can do. So I'll go ahead and show you this right now. If you want to find the log base 3 of 4, it's the same thing as, I know I'm going to need more room, so I might as well just do it now. Log base 3 of 4 is the same thing as the log base 3 of 20 over 5. You can argue that if you want to, but what's 20 divided by 5? 4. Okay, everything's the same. No, you don't cross it out, because you have to figure out what it's equal to, and crossing that out doesn't figure out what it's equal to. So here we go, and 4 equals 4, yeah, I know that. Big deal. So here's what we're going to do. We're going to use the quotient property of logarithms on this problem and expand it. Okay, so if I expand this, it's the log base 3 of 20 subtracted by log base 3 of 5. I know what the log base 3 of 20 is. It's 2.7268. At least that's what I was given. And yeah, you would be given this if you were expected to solve a typical or a similar type of problem. So it's 2.7268 subtracted by log base 3 of 5 is 1.465. I'm going to be honest, I can't do subtraction like this. I just can't. I never learned it. I can do it like this though. I can't do it the other way though. It's well, especially now with those numbers, it's too tricky for me. I don't have a calculator, so that's a problem too. 8, 1, 12 is 6, that turns into 6, 2, 1.2618. Woo, I hope I'm right. Don't see why I wouldn't be. So that's basically it. That's how you can use the quotient property of logarithms. Other than that, I hope that's helpful. Have a good day.